For the sake of everybody in the bank, act like you got some sense.
Let's go. See, this is actually even working. Yeah, look at that. Pretty rad. Cool. Here we are multi-streaming. My name is Mike Barmundi. I go by Mikey B. Nice to see you. And today we're going through all the isms we had before when it comes to what's going on here with our AI Homelab. So let's get to it. We're trying to create an AI Homelab with Nutanix. It's a little late in the day for me, but I wanted to get to this because I think it's super important. And we went through some stuff. So originally I was live streaming on Twitch, and now we are simulcasting, I don't know, to both YouTube and Twitch, which is pretty cool, based on what's going on here. So kind of a cool way to kind of get going with things and figure out what's happening. But the whole focus today is, hey, can we get Nutanix set up for AI as kind of an LLM backend to run Nathan and do some agentic stuff? That's the whole purpose from a Homelab perspective, right? So this is version, this is part 3.75 out of who knows. I'm just going to take some notes here so that we can figure out where we're going. But essentially, what's going on here is that we're trying to figure out exactly what went wrong on Twitch in the previous 3.5 iterations. We've had some issues with running this, and here's some reasons why. One is that NAI is, let me build this up here. Oops, it's too big. NAI is exclusively K8s, so it's Kubernetes at its core, which is super interesting because that means it's hard from an enterprise perspective to kind of figure out exactly what's going on and what's happening. So it's K8s at its core. That makes it super difficult to kind of figure out, hey, can you run this in your home lab? I'm used to Docker, honestly, so this makes it interesting. So we're using micro K8s, and we have an amazing guide from a colleague of mine called Simon Todd, who kind of set this up, and I will throw the link in there, and you guys can take a look at it if you want to when we're done. So we ran into two massive issues. Both are like WTF moments. One is for the first couple tries, we didn't have enough resources. What? Are you serious? Yeah. So what was happening is we needed, and this is where we're standing on right now in terms of hardware, is 28 vCPUs and 82 gigs of RAM. Now, again, I'm going to specify I'm going to be very specific here. These were things that I set on my server I have under my desk. I bought before the RAM apocalypse. So I have a lot of RAM here, DDR4, 128 gigs. So we're using 82 of this, and then we're using 28 vCPUs. And you're saying vCPUs for Kubernetes? Yeah, we're running this in a VM. It is running just the core kind of, sorry, my mind went blank. Kimu is what it's running, and then it's running VMM on top of that. So basically it's a VM that's running these things, and we're running in this configuration here. The other thing that's interesting is we're also adding to the mix, and this is what we hope to get to today, an RTX 3090. So this is just your, I guess you could call it run-of-the-mill 24 gig VRAM when it comes to what we're kind of running here on the GPU side, and we're hoping to get that all working. Again, these are all kind of home components for this. I really hope to be able to get this RAM and vCPU requirement down No guarantees yet. So this was issue number one, is we needed this. And the other kind of sub issue to this is that we needed storage. And I had originally set up this VM. It's running Ubuntu in its core with only 100 gigs, and it wasn't taking all that. So basically it's an NFS share I have running at home, and now we're running on 300 gigs, which is rad. So let's take a look at that really quick. So here, blow this up so you can see my code side. This is the DF side of what we have storage-wise. You can see all my Kubernetes stuff. But here we go. Here's the new resize partition. So we're hitting about 294 gigs total that we have available. We've only used 55. It's thin provision, so it kind of grows as it goes. Thin provision, can you use that with NFS? We don't have a quota, and it can grow into that. So I have a whole guide that I'll list to you about how I did that in terms of, hey, I need more space. What do I do? We can get going there. So that's kind of cool. Kind of going back to the full side of things. So we know that was the first constraint, is we needed resources was the big problem. So number two that we didn't have, and this was crazy to me, is that I spent a lot of time, I think it was yesterday, troubleshooting all these errors and things. Part of it was because of the storage portion, where all of a sudden I would try to download a model, and we'll get to that, and it just broke and the whole Kubernetes cluster blew up. And the other thing that happened was wrong credentials. So at Nutanix, we have this POC NFR license that we can use, and come to find out that we need Docker Hub credentials, because that's where we store a lot of our core images for Kubernetes. Those had recently been changed, so I was using bad credentials, and it took us a long time to go through and figure out exactly that was the case. So now both those things are good to go. And I said yesterday that I would take some time to figure this out, and good news, I have. So this is for LLMs and endpoints. And so today what we hope to do, again, like we've been wanting to for the past little while, is to get Nutanix Enterprise AI up and running, where we can download an endpoint and use it as an inferencing backend with an API that we can then give Nathan, and then we could be off and running. All right, pretty cool. So let's take a look at what this looks like from an NAI standpoint. So before I get into that, the big problem we were having, and this is the Nutanix Enterprise interface on the left-hand side, is that these models that we were having, that we have here, were not working. Basically, what was happening was that the status would stick in just downloading. Come to find out, it was a storage issue, and we were actually able to trace back the networking piece to see that, hey, it was trying to download this model. Initially, it wasn't because of the wrong credentials, and then it was, and then it failed because of the storage. And now here we are. So you can see there's all this, I would say, classic complexity when it comes to setting up Kubernetes and things, which is you still have to understand the infrastructure beneath you. I saw today internally at Nutanix, and part of my role as a technical evangelist, so that's why I'm doing these things, is today someone had actually pointed Cursor, a colleague of mine, to some of this documentation we're following by Simon Todd here. And he actually told Cursor, hey, go out here and figure this out and get this working. And apparently it did. So that's a super rad thing that I never considered in terms of being able to do that. I think the agentic flow of things is moving so quickly, it's hard to actually understand where things are going and what's happening. But suffice it to say, we are in better shape now. All right. So with all that being said, I said yesterday I was going to take everything offline. I was going to expand the storage, which I did without actually deleting the VM, which was kind of interesting and cool. And then the key part was, hey, can I download the models so that we can be ready? And good news is I did. So that's all completed. We are all set and good to go. And we are ready to roll when it comes to actually creating an endpoint and testing it. So let's actually do that right now. So I'm gonna clear some space. I have a scratch pad over here that I use offline. Sometimes I will take things down if there's sensitive information, just to make sure that there's no like secret keys being shared, and that kind of stuff. I've been pretty good about it, so we'll see if it continues. All right, so step one in Nutanix Enterprise AI, because really what it is at the end of the day, NAI, as we call it, Nutanix Enterprise AI, is an enterprise scale LLM inferencing platform. Meaning you can take this, put it in your enterprise, get purview and context across all the LLMs that you implement privately and securely. And we have these model repositories of models from Hugging Face as well as NVIDIA. I'll blow this up really quick so you can see it. Or you can even do a manual import, and you can even run this thing in an air-gapped environment. Haven't done that yet. Again, we're taking a Homelab approach. And so what we've done is we've taken a Hugging Face model, a Mistral 7B. Again, it should fit on my RTX 3090 card, and we should be able to run it. So the other thing is that NAI has a very tight GPU supportability matrix. For Hugging Face, it's pretty open. There is no completely disallow list, but for NVIDIA, there is. So the NVIDIA NGC catalog, which covers its suite of software called NVIDIA AI Enterprise, they call it NVAIE sometimes. Everything's an acronym, right? Like, holy crap. So NVAIE has what's called NVIDIA NIMs, and these NIMs are like containerized versions of models and different things that they put out there that you can then use. Nutanix Enterprise AI can integrate those, but it has a very strict GPU list. And so obviously an RTX 3090, no, they want like an H100. They want like a B200. They want like an RTX 6000 Pro. All things that are way above what I have or I want to pay for in a Homelab. I will say there is a secret sauce here that we'll get to when we create the model, and that's that you can actually use inferencing with no GPU at all. Kind of cool. But that takes some specialized hardware too. Everything requires hardware, right? Let's not try to make it what it's not. So part of this as well is that Nutanix also has what's called a model access control list. So it's off by default, meaning that when you decide, hey, I want to pull these models down, we have a succinct list of models. These are called pre-validated models, where we do all the hard work on the Nutanix side to figure out how to do your CPU, your GPU sizing, their storage requirements, and we bundle that all up and say, cool, here's this model. We've already done this. Put us on your hardware and you're guaranteed, and we'll support you to run it. So these numbers here, 30 and 32, most of these are pre-validated. And then, of course, you can actually do non-pre-validated. So clicking this box, allow direct download using model URL, and it'll give you a warning. Hey, you want to do this? We're like, yeah. That'll allow you to actually go and copy a Hugging Face slug directly, so you can grab that model and throw it in. And then if you want to, in an air-gapped environment, you can do an allow manual upload, where once again, you can configure, almost to your heart's content, the minutia of things needed to run that LLM in an air-gapped environment. But we're not going to do that. We're going to take the easy way and say, hey, we got internet connectivity. It's a Homelab. Let's go. So part of this is I had to allow this Mistral 7B model. So this is now an allowed model, and I actually complained when I did until I clicked it, and then it went out and downloaded it. So again, the Nutanix piece has RBAC on the back end, role-based access controls, so you can control who has access, who doesn't, and whatnot from that perspective. Dang, raining outside. Maybe you can hear it, maybe you can't. I don't know. All right, cool. So that's the model access control. That's where we're at. And now we are ready to take a model, and we're actually ready to create an endpoint. So what's an endpoint, you say? Well, an endpoints are basically taking your model, your LLM that you want to use, and putting in a package and then wrapping that in an API that you then give to an application like Naton or a chatbot, and you can actually run inferencing against it, which is like, hey, it's like ChatGPT-like, which is pretty cool. So now we're going to try to create an endpoint with our RTX 3090. All right, here we go. So, man, it is raining hard all of a sudden. I don't know if you guys can hear that, but dang, that's crazy. All right, so we're going to give this endpoint name. I'm going to call it Mikey B. I'm going to blow this up so we can see it. I'm going to call this Mikey B Mistral 7B. And it's pretty good. It'll tell you if it's problematic or not in terms of the naming. And we're going to give it a description. There we are. And then we're going to select model capabilities. So this is a way, this is a way that we can actually look at all the different model capabilities, from text to tool calling to reasoning to re-ranking to embedding. We actually categorize these so we can actually chain them on the back end to do different things, as well as allow certain capabilities. So you can select multiple, like as an example, this was a Mistral model that could do text and tool calling. You could add those both and it would expose that. We're just going to do text. We're going to keep it simple. And then we're going to select the model instance name. So you can see here, this is the model I downloaded. So here's the Mistral 7B, and here's the acceleration type. And this is the key right here. You can do CPU-based inferencing. Again, no GPU needed, or you can do GPU pass-through. We are going to do GPU pass-through to see if we can get our RTX 3090 working. If not, we're going to go back, and you can see, cool, it sees our GPU. That's pretty rad. We're going to go back and choose CPU if that doesn't work. I do have an AMD 5950X, so definitely not optimized for AI inferencing with kind of enterprise instruction sets like AMD or Intel have. But hey, it works better than nothing if you want to try something out. So we're going to pick our 3090. And then, again, part of this is configuring the endpoint for what it's going to use inferencing-wise. And then we're going to configure the API, which we're going to do here. So we're going to enter the key name. I'm going to call it Mikey B, Mistral 7B API. Real original. And I'm going to copy this because that key name is going to be important in a second. And then here is the key we're going to use. Notice like most API pieces out there, and I'm okay exposing this online because this is just my private endpoint that's here. So I'm going to copy this key, which copies the key name as well. You could expose this to the internet through a series of things if you wanted to, and there's some new things coming out for Nutanix that'll even make that even more powerful. But for now, we're going to copy that. I'm going to throw it onto my pad over here that we can have, and then I'm going to click Next. All right. So now that the basics are done, as it says up here, now we're on to the configuration of the endpoint. So now we can actually determine, hey, what kind of compute configuration do we want? Because this is a pre-validated model, a lot of these things are filled in for you. But if you notice here, you can start to scale and you can see the power, which we're not going to do here at the Homelab level. But what we are going to do is just show you some of these options. So you can see the number of accelerators per instance, meaning, hey, I want to do, this GPU per instance, and it'll scale across the number of LLMs that you have. You can say, hey, these are the number of instances I want, right? So these can match up or they can be different, and you can see the max number of tokens that are provided there based on the accelerators as well. So you can start to kind of scale this and get an idea of like how to plan for, hey, if I have, 6 GPUs, then maybe I want 6 different instances, and what does that look like? So if I picked 4 here, I could pick 4 instances and then make sure, in this case, I would have, 4 accelerators per instance, where if I kept this as 1, I would have 1 accelerator per each of the 4 instances. So it's actually interesting. I wish they'd probably like make that math a little bit more intelligent, but for now, we'll just keep it as 1 as 1. All right, so you can see here, this is where the pre-validation comes in. So we have vCPUs here per instance. We have memory per instance. This memory, I'm assuming, is based on VRAM, but I'm not quite sure. But you can actually use custom, and you can actually change these if you'd like, but we're just going to keep it as default because that's what I like to do. Context length is, and this is actually a pretty good description, where in AI, it's all about a token. What a token is, it's an arbitrary value that AI uses to translate whatever you're inputting into it into something that it can consume. It can run through its weights and biases, and then it can run through its neural network and then spit out something, again, in the form of a token that you can understand. Kind of like humans do. We do it naturally. Like I'm speaking to you, you're listening. Well, no one's listening. That's okay though. And from there, we can actually translate actually what's happening and what's going on, and we can actually get a better idea of things that are in flux. So the context length by default is 32,000. You can see here, that's about 275 words per page and about 90 pages, the maximum number of tokens a model can process in a single input. I think that'll be okay for us for now. But it says, hey, these settings can't be changed once the endpoint's created. One thing we can do, if we'd like, is we can go to Hugging Face. Let's go there really quick. Let me see if I can find, here we go, the Mistral model, and it will probably give us exactly what the max token size is. So it says here, here's the max extended vocabulary to 32,768, which absolutely matches our context length here. It probably, the pre-validated model probably already pulled that in. So we're going to leave that at default and we can go. So you can start to see the correlation between, how things are connected and how things are done. All right, cool. So now we are going to go to kind of the summary page. So it gives us all these details, the endpoint name, the description, the pass-through, all these things, and we're going to click Create. So endpoint creation submitted. It says pending here. I know it's kind of hard to see. I've tried to optimize my screen for different things. The pre-checks are in process. And so it's doing some pre-checks based on, hey, are all the things under the covers good to go? Can I actually fit this on what I need to? And then it shows initializing. So one thing we could do at the same time is we can do an NVIDIA. Do I have that? An NV top? Yeah, we do. Okay, cool. So now we can start to see, hey, you know, are we pulling in what we're saying we're doing? It's initializing, and then we can actually see on the underlying hardware if it's starting to actually use that that GPU for inferencing or whatnot. Again, I have no idea if this is going to work because this is an unsupported card. I'm guessing it should fit on here, but TBD. So I'm seeing here that the memory is just chilling out. It's still initializing. Sorry. So I'm not sure exactly what's going on here, but I have learned a couple of things that we can do under the covers. We can look for is that we can look for tasks. So here's the Mistral task that's going on right now. So you can see it's creating the container. This is something new that I've worked with in terms of AI. I think the other big piece for all you that are new on YouTube is that we're using Perplexity as kind of this running tally of actually how to set things up when we don't know something. My personal belief is that a lot of workflows these days are now not necessarily SME focused, like, hey, Bob, do you know how to do this? And even not Google focused, like, hey, Stack Overflow, what do you think about this? Or do I search for something that maybe someone's already solved? It really comes down to, hey, can AI make this work for me very quickly? And so what we've been doing here is when we come up against something like this, we're like, hey, I don't know what's going on. AI, I get, container error. What does that mean? And it actually walks us through the steps eventually. So it's one of those things that I think it's important to garner as a skill in this kind of new world of AI. I'm a big believer, as we're still, I think, creating this here. I'm a big believer that these AI components are really tools at the end of the day. They're not replacement components. Even with the most advanced agents today, right? We've all heard about OpenClaw. We've all heard about all these crazy ways that agents are happening. You still need humans in the mix to figure out how to make these things work. And it can get really complex. And the most important thing here is the context around what we're trying to do. And so you need to be able to, A, use these tools, B, understand how to interact with them, and then C, leverage their output for your day-to-day stuff. And that can get tricky for sure. So from that perspective, I think we're definitely wanting to kind of push the envelope on how I think a normal, IT person in an enterprise works with IT these days. I could be wrong, right? I think there's a lot of different. Oh, that's interesting. Just went to unavailable. I'm not sure why. Let's see if it still says container creating. So I don't know what's happening here. So we'll have to figure that out. Oh, and there it goes to pending. So it's creating another one or a secondary one. I don't know. All right. Well, we'll just let it roll and see as we sit here and talk. But I could be wrong about the expertise. In fact, I know I am in the enterprise. I think there's a lot of varied skill sets. Some people are more eager to learn these things. I noticed that because I did IT for about 15 years, is that there's certain technologies I gravitated towards. Virtualization was one. Virtual desktops were another. Those are things that I really gravitated towards that were like, oh, I want to learn that. I missed the whole public cloud kind of DevOps thing because I was on a different path with my career. But I totally understand how those type of things would be more interesting. I've always been personally, I can't code. That's just not me. I can't. I can't sit down and just open up an IDE and then start to code and look at a code base and understand things and then create. I can't do any of that. Maybe I think it's just a mindset that certain people have. I think from my perspective, it's pretty interesting in terms of how that's kind of led me down certain paths and how things kind of come around. I know I'm kind of just blabbing on here, but what I'm saying is that what's really happening is that, in my opinion, we're gravitating back towards that. I'll give you an example. in terms of having these tools that can be used. Like I just created, was helping some of my hobbies. I do this online video stuff, and I helped a community that I'm a part of, and they're really cool people, and I love to help them. They needed some integration with this application that they were using to stream video with, and some things happened, and they needed someone to step in and help, and so I did. I didn't know anything about it, and so I took to AI and said, "Hey, look, I've got this platform. I have this, this video kind of repository that I want to stream to, this app. What do I do and how do I do it best?" And that started like a 4-week journey of me, getting done with work, being on my laptop, doing those things where I could actually sit down and go through that. So it was kind of cool to go through and get all those steps from, hey, I want to be able to take an MP4 video and put it on this platform and then actually turn it into a streaming video versus just MP4 and letting the internet do it because of the way the streaming works, right? You want to break it up into chunks I've learned called HLS. Well, AI walked me through how to do that. Not only that, it looked at the code, because this is an open source repository for this video program called Media CMS. It ingested that, and then it looked and said, yeah, this is cool. This is how you do it. This is what you should do. This is what's going on. And it was really awesome to kind of see all that kind of come to fruition. So the vibe coding, whatever you want to call it, it's definitely a thing. It's definitely something that you can leverage. And, I think it does take that know-how to know what's going on and then going through it. All right. It's kind of weird having your own platform because you can just blab on and no one really knows. But here we are. So with that, we're still initializing on this thing. I'm not quite sure what's happening. So it's pending. I can definitely see that the container is being created. Let me see if we have any tricks over here. And we can ask AI as well. Like, hey, I see this, and again, this is how we've been using AI. So let's just jump into it. So I'm using Perplexity. I have the model I've been using. Oh man, they just upgraded just today. Claude Sonnet 4.6 thinking. Oh man, this should be interesting. Heard some good things. I don't have access to Opus. I'm not super rich from that perspective, obviously. So what I'm going to try to do is say, hey, we're deploying. Jeez Louise, an endpoint on Nutanix Enterprise AI 2.5 is the version. And let me just take a look at this really quick just to make sure that, okay, there we go, cool. And just let me make sure it's still pending, and it is. All right. With an RTX 3090, 24 gigs VRAM. One thing I've learned about AI is more verbose you can be about what's happening, whether you think it's important or not, the better it can actually give you an answer. With VLLM and Mistral 7B instruct. I'll even give it, what is it, the 0.3 version. We're seeing it's a lot harder to talk and type at the same time. Like, I'm an okay typer, but this makes me seem like I'm just hunting and pecking. I'm not. I'm using both hands. We're seeing a pending status in the NAI interface. How can I see what's happening at the micro case level? All right, so let's see what it says. I don't know what it's going to say or do here. Again, it's still pending here. I can see the container's creating, but it's not really doing anything. This is pretty indicative of what we've seen before. So let's see. Here's a systemic rundown. Pending means the system is waiting for required resources, most commonly the GPU, before it can enable things. With a single RTX 3090, the culprit's almost always GPU visibility, driver, or resource scheduling issue. So NAI runs in a control plane. an NAI system namespace. It's correct. So we can always check the pods and see what the status are here. So one thing I've learned about AI is that you always read to the end before you start doing things. I have a real issue with that, as you just saw, because a lot of these core commands, especially in thinking or reasoning mode, it'll spit out all this stuff, and at the very end, it'll be like, okay, go do this and give me the feedback, or do this and let me know what it says, and then it'll go from there. Here's how you find the inference pod. Here's a core diagnostic commands, and you can verify your GPU operator health. Doesn't show up as allocatable. GPU operator isn't healthy. No amount of NAI level debugging will fix this. All right, so a few things specific to your hardware. Check the logs, quick support bumble. And here we go. The most actual step is running this, your Mistral pod namespace, and sharing the event section. That'll pinpoint whether it's a GPU scheduling failure, image pull issue, or PVC binding problem. All right, so it's still hanging out and pending. So we need to find your Mistral pod. And so we go up to the describe commands. I think there's probably, again, we kind of just used it like I'm talking to a human, not knowing that we need to give it things like, oh yeah, here's this layout, or here's that. Or hey, will you make sure that you put the commands in at the end of every single one of our threads so that when you go through all these commands, you just succinctly give us what we need. Sometimes you need to do that. I have some prompts that I use for other things that I've collectively built on, and I start everything with those. Like that media CMS project I was talking about, I have one. This, we're kind of just doing it really ad hoc. So let's describe this. So we are going to start with, let's get the namespaces, and here are the pods that are running. So let's see where it is. So there's the pod that's running here. Cool. So then it says, hey, take this, and there's my key over here that we had, my API key that I copied just to my scratch pad. And let's describe that pod. So let's go ahead and do that. I'm actually going to copy all these commands and just throw this in so we can paste them quick. And then we won't have to worry about going back and figuring that out again. Endpoint namespace. That's interesting. What is that? Find the inference pod. Once you spot your inference pod, run these in order. Oh, it's the endpoint namespace. So sorry, I think this is just NAI system is what this one probably is, I imagine. Yeah. And then list all namespaces to find your endpoints namespace. I guess it's asking, hey, is there another endpoint namespace? But I think it's probably NAI system. Well, we'll figure it out. I think that's the key is saying, hey, I think it's going to all fall under here. It didn't really specify exactly if that was the case or not. But let's pod name. All right, and then pod name. Okay, cool. So I got these all copied in. Let's see if these actually work the say they're going to do. So I'm going to do a clear here, blow it up a little bit, and let's see. So the pod's not found. So error from server on NAI system, that's not sound. So it's got to be somewhere else. So if I get all the pods in the NAI system, hold on one second here. I might have missed a step or misunderstood something. Oops. So here they all are, pods in the NAI system. And then list all namespaces to find your endpoints namespace, which this is where it got murky for me. Oops, I keep wanting to right click. I just do this. And then, so here, where's our Mistral 7 job? I'm trying to look for it here. I don't see it up here, but yeah, that's kind of interesting. So find the inference pod, usually named after your endpoint. Oh, it's the endpoint name. So if I put this in, okay, there's the endpoint name. So this is the endpoint, which makes sense. And so endpoint namespace, did I have it backwards? Check NAI plane control pods. I'm a little confused on what this means. In terms of what's happening, let's just check back on this. Still just hanging out there. Once you spot your endpoints pod, run these in order. So I'm guessing that's the pod. So describe pod name. So again, I don't know. I'm just going to delete this and just not found, pods not found. I wish someone was online to tell me what to do or what I was doing wrong, but there is no one, and that's okay. So I'm going to copy this command back over. I'm going to fill in the blanks. Describe the pod. I am unsure of how to find the pod name where the endpoint lives. I ran the command. Let's just tell it that we found this, but I don't know what the name of this one is. I ran this because this is find the inference pod, usually named after your endpoint. Ran the command this, and we got, let's peel it off here, this guy. All right, let's see what it says. Again, I like playing dumb with this, and this is one of the, I think, the best, most intriguing things about AI is exactly how this works. So perfect, you've got the pod name. So that's what the pod name is. So pod name equals this. So now it's gonna help, all right. So get the full output, including the namespace column. Okay, here we go. So let's see what it gives us here. Oh, so NAI admin. All right. So my bad. So I had it system, but it should be NAI admin. Why? I don't know. Now we run this in here. Let me blow this up. There we go. There's everything. So the NAI admin. Cool. So endpoint equals NAI admin. All right. Let's show you something like this. Yep. Grab the namespace of first column. Then describe pod and namespace. Let's see here. Man, this is a lot of information. Yeah. And namespace. Look for the output. So scroll straight to the bottom of the describe output. The events in your section is a diagnostic gold mine, it says. All right. Node Kubernetes. Pulling. So it's pulling this. It's pulling VLLM is what it's pulling. Oh, interesting. Okay. So I guess if we do a, I wonder if it's still pulling, just pulling down stuff. So let's see what AI wants us to do. Sorry, my mind goes like, I could go 4 different ways now. So back off, other nodes, check log simultaneously. So let's, again, I'm going to copy the events here really quick. Drop the events section output here and we can pinpoint. Here's the events. All right, there we go. So now if I go here, let me see if I can get my if. Where is it? Where is my guy here? Good news, there's no scheduling failure. The GPU is visible and pod was. It's currently pulling the LLM container image, which is a large image, 20 to 30, depending on CUDA layers. Oh, okay. So now if we looked at, I think the bandwidth, we could actually see this actually happening. So if I do a sudo if top, here we go here. This will help, I think. Oops. Oh, there it was. Jeez Louise, Michael. All right. We should see our bandwidth pretty maxed. Yeah, and there we go. Okay. So I have about 350 megabit connection, so that's about right. And we'd see we're calling out to these IPs, and I think we're in good shape in terms of what is grabbing. If we looked at a df-h2, I'm imagining that that's going to show some pretty substantial growth as well. Yeah, on what we have running on the storage piece. Okay, cool. So we can watch it live. Oh yeah, here you go. Here's how to watch it live. So here's the namespace. So let's see if this command works. If we do this, then we just do, I think it's NAI admin, which is the namespace. Oops. Of course. Why does it have to be, why can't it be easy? All right, so, all right, so it's still just pulling it. All right, that doesn't help. So RX-wise, that's a cumulative, that's the RX, and then we can see the rates that it's going at. So we're humming. It's just taking a while. Still pending. It's been about 20 minutes, which fantastic. I love watching paint dry. Seems to be a lot of this all the time. So regardless, it's rolling along. It's pulling down this image, and we're in good shape. So that's helpful from this. So container, it goes from pending to container creating to running. And we're definitely at the container creating stage at this point. So we can watch a pull progress directly if we do this. So I can open up another terminal as well and do it there. So now we can watch, and I don't know what this is going to show outside of it. So, oh, okay, interesting. And we'll get metrics for resource. Warning, pulling, warning, failed, compute metrics replicas. All right, well, metrics are the last thing I'm worried about right now. That'll change in the future, but for right now, I don't care. I think we're fine as is. I think we're totally fine. Oh, thank you, Grading Minds, Rad 7 Vra. Cheap viewers. Go to that link to get cheap viewers. Man, you can't just escape spam these days. Like, even in chat, like, spam all over the place. Rad. My favorite thing. Oh, okay. Is it done? Let's see. No, it's still container creating. So maybe it's just a timeout of what's happening. So it's still pulling it. Pulling that image. Pulling. Sure how long it's going to take, but here we are, just pulling it. Once it pulls, you'll see normal pulled kubelet successfully pulled created. If it's been pulling 15-20 minutes, it could be a bandwidth bottleneck or a silent pull failure. Check on the node directly. All right, so let's do this. Let's check on this node directly. Let's see what's going on here. Bandwidth is still just going crazy. It's like it's its max, so it's still definitely pulling. And that could just be my internet. Like, who knows? Oh, whoops. So copy this. Let's clear this out, and then let's see what it's here. So crit CTL, it's not available. Let me see what it's doing here. Oh, man. I think it's a storage constraint. Again, it's NFS. It's an NFS share over the network, so I don't know what CryCTL is. SSH in the NAI node, then check, SSH in the NAI node, then check container D pull activity, which, whatever. Or you can watch this directly. All right, let's watch the journal because I know that that's on here. Should be, right? I mean, you should have a journal CTL entry. Bottom line, sit tight. All right, fair enough. Still telling me to sit tight. We're way beyond that now, but it is what it is. So let's see if we can jump back into, where's that super cool command that kind of listed the events as well. Not that one. Here, let me go up here and just find it. So one thing you'll notice too is at the end of all this, I'm gonna, and into this AI piece, I'm gonna do like a summary and be like, hey, document what worked, what didn't, and it does a really good job of spitting that out. So I think that'll be great to have that. Pending, get the full output, including the namespace column. So this is the one here. All right. So here's the full output. No, that's not the full output. And then grab that namespace column. Oh, okay, there it is here. So NAI admin. Now I understand. Now I get it. I'm so slow. So still pulling, is pulling, just pulling. So much pulling. Once you reach, no new endpoints should be created. Oh, that's interesting. So I wonder what it's saying. Maybe it's pulling the, well, nothing's happening there. So I don't know what it's talking about. I mean, I guess If it gets within like 10% or something like that of things, it'd be interesting. Let's look at the licensing really quick. I mean, all right, whatever. We're 80% of limit because that's how much GPU that's on the card. So whatever. I gave it, when I created the license, I'm like, just give me 30 because we won't hit that because there's only 24 physical gigs of memory on that card. So a VRAM, whatever. Well, you can go away then. See you later. All right, endpoint still pending, still hanging out. And we are just waiting. Okay, so this just slowed down, like way down. Still says pulling, but still says container creating, so maybe we're just hanging out. Please don't start pulling again. It's not. It's not at all. You can see some of my other devices in my house here. It still says creating. So yeah, we're just gonna have to, I guess, wait on that. So grab the namespace, wait to look for, check log simultaneously. Drop the event section here, which we did. Sorry, I was behind. Sit tight for now. Yeah, we can always do this. So let's do it here. We'll do NAI. Again, this is not going to give us anything outside of, hey, it's just container creating, I think. Oh, okay. More invalid metrics, readiness probe, connection confused, warning unhealthy. Okay. So it's definitely, sorry, I'm trying to figure out how to make this bigger. What I might do is just, so it started it, it's unhealthy, connection refused. That's interesting. So they dialed in the TCP at 8,000, the connection was refused. Again, I don't know if these are normal or not. Unhealthy. Readiness probe failed, connection refused. Oh, let's play it again. No. Please no. Why? Are we really going to pull it again? Shouldn't. It says normal pulling. Still pulling image, so maybe it still thinks it is. I don't know. So I see using the command. We'll get out of this really quick. We'll scrunch this back down to normal size so that we're all in the know. So I see some logs based on the command. By the way, it's been like how long? Oh, it says processing now. That's interesting. Okay. Well, that's an improvement. Oh, everything service ready. Okay, so again, oh, active. Yeah. All right. Well, okay then. Jeez. Every time, it's always my impatience that gets me. Every single time. I mean, most of the time. I mean, sometimes, but most of the time. All right, so now that it's active, right, let's see how it's loaded up. Oh, look at that. You see that? Holy crap. That memory up here, look at that. My card is now pegged at 22 gigs. Holy cow, that's pretty rad. Cool. Okay, so it's definitely using the card. So it's got the model loaded. It's probably humming. That's only 31 degrees. Like I have a pretty decent cooling setup. All right, sorry, I'm just excited. All right, so let's take, so one of the cool things, okay, let's take a step back. Model, check. Endpoint, check. Now we're like, well, how do we test it? Well, there's a couple of things you can do. Number one is I can jump into this model and I can see a bunch of different things. As you can see here, I can see that it's the model. I can see it's active. I can see endpoint access, token usage, request. There's nothing because we haven't ran any of that yet. The memory per instance, all this stuff. I can refresh it. Obviously, nothing's going to happen. The other thing I can do here is I can look at the logs. So here's all the latest logs, which are cool on a per proportion basis. This might be the issue we were seeing around the metrics, but I don't think that's the case yet. But one of the other cool things you can do, I'm trying to figure out where it is. So I can get into here and I can edit it. No, I can just edit the instances. There's a thing called pre-flight where I can actually take a model. Maybe it's the model side here. And no, it's not there either. I wonder where they put it. Huh. Anyway, there's this way that you could actually test it, but I guess it's kind of irrelevant now because the one thing we can do, so getting into here, here's a sample request. So this is the way that endpoints can be accessed using the URL and API key. So if we wanted to, we could curl this. Maybe we can test this really quick, right? Let's just do it like this. So I'm going to get out of here. I'm going to clear this. And I'm going to throw this information, into my notepad and fill out some of these pieces that I need. Well, that's what happens when I accidentally hit copy instead of paste. And then I'm going to throw in my key here, my API bearer key, and I'm going to see if we can actually curl a response directly from it. All right, here we go. You ready? API key is not provided. All right, well, I screwed up the format or something. I put it right after the $, so maybe I don't need the $. I don't know. I just know it's malformatted. I'm doing something stupid. Failed to validate. So API key, I just replaced it right there. That should be it, right? I think. Unless that's the correct one. Oh, sorry. Well, that would be why, is because I'm copying the wrong the wrong API key. I was doing the Hugging Face one, which fantastic. Which doesn't matter. I can get rid of that later. And not the NAI key. Where did I put that? Dang it, Michael. Why do you got to be like this? Of course, I had to do this. Okay, no, that's not it. Nope, it's fine. Oops. Fine, Mistral. On current document. All right, there it is, finally. All right, I don't know why I missed it. Okay, cool. So going back up to, where do I put this? Oh, good gravy, I need to clean this out. All right, so going back up here. Okay, here we go. I'm going to put that $sign back in because that probably creates a variable that it uses. I'm going to curl this and see what we get. All right. Here we go. Nope, I got to copy it. Not just right-click it. Fail to validate. Type unauthorized. Okay, so do I remove the $sign now? I mean, maybe. Model messages. Maybe I can't go against myself here. Wait a minute, something's happening. I removed the $sign. Oh, there it is. Deep neural networks are a type of artificial intelligence model based on inspiring idea. All right, rad, it's working. I am doing inferencing via curl. That's pretty sick. Okay, so that $sign goes away and it's just, okay, whatever. I read too much into these things. So this is the other cool thing you can do with Nutanix Enterprise AI. In 2.5, we built in this thing called NAI Labs. So this is a way to actually test non-production applications right off the bat. So if we go to chat now, and in chat, I can select my endpoint name, I can throw in the API key, and now I actually have an app here where I can actually chat with it. Like, hey, you know, tell me, whoops. Oh, it is, okay, it's just, this was not made for, I'm going to switch over really quick here to the bigger screen because I think it'd be more helpful. So here we're going to go full and I'm going to save this. And so here's the prompt. So we're going to type in here. We could ask anything, right? Like, tell me about your opinion on the French Revolution of, and this is worthless, right? The 1750s. seems to be a mistake in your question. See, it corrected me. Oh, look at that, man. It's inferencing right away. And we can probably see the peaks and valleys now on NVTop. So we can definitely see the compute side go up and then it comes down. It was a transformative event. Oh, it was late 18th century. Oh, tell me about that. Oh, sorry. So it's going to tell me about that. And then what we can see if we switch back over to the code view, oh, look at that. Look at that beautiful, beautiful little peak and valley of inferencing, of compute that it's running those beautiful CUDA cores against. So pretty awesome. And you can see here, it's the VLLM engine core. So we're actually doing inferencing on a 3090, which is great. So yeah, it's kind of it's 7B model. It's not that smart. Tell me about Nutanix HCI. Misspelling a reference. Nutanix is a company. HCI Solutions. Oh, I misspelled it. That's why. Yeah. Sorry. Misspelled that. Tell me about the key value prop for Nutanix HCI. All right, there you go. So it's not going out to the internet. It's not going to anything. It's staying 100% local, and it's giving us, you know, all these different things. I'm not sure when this model was buttoned up, in terms of like, hey, it was trained and then it was capped. Like, I'm not sure, but oh, let me go back to the full view and you can see that. Sorry, my bad. So you can see how it just spit that all out. So we're in good shape, man. Like, this is working. So now, all right, cool. We have an API endpoint that now we're hoping to connect to Naten, which is pretty rad. So we're in good shape. So let's go back to this. So Google Docs, in terms of the entitled. So today we won, right? And this is what I wanted to do. We deployed Mistral 7B. Check. We deployed a VLLM endpoint with an API. Check. And if you go and you look at the code view, back to here, you can see how everything is just humming and everything is working. The memory's full and it's just hanging out, doing its thing, being great. So everything is working swimmingly. And now we have an API that's ready to go. And now, again, if we go back and look at the dashboard now, you can now see, oh man, we have data. So we have active endpoints, successful requests in terms of API calls, the number of requests, everything's healthy. Oh, this is fantastic. So here's the audit events, here's the infrastructure that's running on, here's the users. So, and again, we can go into the endpoint now and we can see requests, we can see the token usage. Let's see if I can blow it up, but let me just do it over here. I don't know what I'm thinking. I'm gonna go full screen over here. Go to the dashboard, and then endpoints. So you can see here that we have successful requests. We have, I'll move myself out of the way here for a second. We have input tokens, right? So we can track token usage. So we've already used like 3,000. That's crazy, right? That's how quickly this adds up. And here's our endpoint URL. So, right, so Naten is going to, I think, at the end of the day, attach to this. The key here is this is an OpenAI compliant API, so we should be in good shape to do what we need. Awesome. Well, that's it for today. I think I'm stoked. This is exactly what I wanted to get out of this. The storage was key. The resources were key. Being patient was key. Downloading these multi-gigabyte models over my 350 meg connection based on where I live is key. And I think we're in good shape now. So thanks for joining with me. I am going to sign off for now, and we'll get back with you soon.